In this video, we will be talking about a lesson that is very integral in our study of some lessons in pre-calculus. So it's basically the fundamental trigonometric identities. We have to know these formulas so that we can be able to solve the certain questions that revolve around these formulas. So yes, let's proceed. Actually, there's nothing much to be written for this lecture, since it's already written before the video even started. So as you can see, it was written on March 5 and now it's March 15. But anyways, that's not necessary to know. Let's start now. So basically, we have 5 trigonometric identity types. We have reciprocal identities, Pythagorean identities, quotient identities, even or odd identities, and co-function identities. As you can see, the highlight colors of luminescent yellow, these 3 identities will be scrutinized in this video. But as for number 4 and 5, the even, odd, and co-function identities, there will not be any explanation for that as of now, especially for the next videos. Although yes, there are formulas stated on those identities, they won't be used in the following videos after this introduction. So for number 1, we have reciprocal identities. Basically, what we have to know for here is that actually there is no brief definition about reciprocal identities. I think, in my opinion, what we have to know about this identity are these formulas. So for sine, by the way, for all these formulas, you have to note that the variable u is used as our mean variable. It could be theta or x or y or at least any letter. So for reciprocal identities, we have sine u is equivalent to 1 over I'm not exactly sure how this CSE is said in whole term. They're basically abbreviations, so maybe it's called cosecant if I'm not mistaken. But what you do have to know is that sine theta is equivalent to 1 over cosecant u. And that also goes for the other way around. So if CSC u or cosecant u is reciprocated, then sine theta will now be 1 over sine theta. So please understand that in this video, whenever there is u, that will always be mentioned as theta, since I'm more used to saying theta more than the variable u. So let's move on. For cos theta, it is equivalent to 1 over secant theta. And as for the other way around, it's also secant theta, it's equivalent to 1 over cos theta. For tan theta, it's equivalent to cotangent theta or cot. And at the other way around, cot theta is equivalent to 1 over tan theta. That's everything for reciprocal identities. You can know that these identities are reciprocal because as literally from the word reciprocal, you reciprocate. So what used to be 1 over cosecant theta is now cosecant theta. What used to be secant theta is now cosecant 1 over cosecant. What used to be secant theta is now what we know as 1 over secant theta, if it's equivalent to cos theta. So I hope you're getting the analogy here. What used to be 1 over cot theta will now be cot theta if it has to be equal to 1 over tan theta. So it's so much thetas. It's quite difficult to speak, maybe tongue twister or some sort. But anyways, back to the actual topic. For Pythagorean identities, literally from the word Pythagorean, these identities relate to the Pythagorean theorem. So I think we all know that a raised to 2 plus b raised to 2 is equivalent to c raised to 2. It's similar to the Pythagorean theorem, but of course there are differences. It's evident all around. So just imagine that this one is our a raised to 2, and this one is our b raised to 2, and this one is our c raised to 2. In that sense, we can derive that, for example, if we're looking for a raised to 2, we have to, I'm sorry, I can't really say much about the comparison between Pythagorean identities and the Pythagorean theorem, but what you have to know is you have to memorize these formulas. Understand that every time you see in an expression sine raised to 2 theta plus cos raised to 2 theta is equal, it will always be equal to 1. So from that formula, we can derive that sine theta, sine raised to 2 theta is equivalent to 1 minus cos raised to 2 theta. Basically, you just manipulate the entire equation and turn it into this. And when you find cos raised to 2 theta, that will always be equal to 1 minus sine raised to 2 theta. Right, give me a few seconds to rearrange my position right now. In the meantime, you might want to review reciprocal and Pythagorean before we move on to quotient identities. So yeah, buy me 5 seconds. Okay, so let's move on to quotient identities. As for quotient identities, they're basically these two identities are basically tan theta and cotangent theta. As for tangent theta, it will always be equal to sine theta over cos theta. As for cotangent, it will always be cos theta over sine theta. So I hope you can see the difference between the two. For tangent theta, it's sine over cos. For cotangent theta, it will always be equal to cos over sine. So I hope that's easy to memorize. I suggest that, I suppose your teacher also allows this. You write all these formulas in an index card or a notebook that you can use for your exam. Well, even if your teacher does not allow you to use to have an index card during the exam, I think it's pretty easy to memorize as long as you practice as long as you apply these identity formulas in actual practice questions. Those practice questions, will be encountering that in the next videos. So as of now, let's proceed to the odd or even identities. As for even identities, they're basically these ones. And for the odd identities, they're these ones. I don't have much explanation on that, since we won't be having practice questions about these two identities at the moment. Maybe I'll be announcing it next time, or maybe not. So yeah. So there's also something that we need to know about this lesson. It's all about the unit circle. So about the unit circle, these are the formulas that you also have to know. You have to commit these to memory, especially if an index card is not allowed in your exam. So for sine theta, I mean, before we even go through the formulas, you have to understand that the r is our hypotenuse. So it's the longest measurement in our triangle. And for letters A and B, so usually we have C, which is equal to R. So our C is usually the hypotenuse, right? So for letter A and letter B, this is why I didn't write any variable that represents the two sides other than the hypotenuse before making this video. Before making this lecture, because I observed that the measurements A and B can be interchanged. So letter A could be here and letter B could be there. that is my observation, although it can be rejected by other observations, but I'm still waiting for that. I'll be waiting for those um, rejections and and the evidences that are below it. So for the unit circle, you have to understand that for sine theta, it's equivalent to y over r. So provided that either you have x here or there, wherever x is, just it's not at the hypotenuse. Um, I'm sorry. If x is missing, you will always place r, the hypotenuse at the front, the highest value, and the other value, which is y, will be the one that's being subtracted from r. So yeah, let's proceed to cos theta. So as for cos theta, it's x over r. For tangent theta, it's y over x. For secant theta, it's r over x. For cosecant theta, it's r over y. For cos theta, it's x over y. Now, earlier, I introduced to you how to solve for x provided that you have r and y. Now, let's solve for y provided that we have let's solve for y provided that we have x and r. In that sense, y raised to 2 is equivalent to a hypotenuse minus the given x. This is how we solve for y. In terms of solving for r, basically, what we have to do is just add the two values that are not the hypotenuse. So this and that. So yeah, another thing that you have to know is about the difference of two squares. In problems about fundamental trigonometric identities, you will be encountering, especially for higher thinking problems, you will be encountering expressions that have this kind of formation. So you have to acknowledge that x raised to 2 minus y raised to 2 is equivalent to x plus y times the quantity x minus y. So yeah, that's it for this video. There's nothing else to commit to memory apart from these. Please expect that we'll be having many practice questions involving these three identities: quotient, reciprocal, and Pythagorean identities. So yeah, thank you for watching this video.